Hello everyone, in this video we'll discuss about vibration isolation mounts. Now we see that in most of the machineries which have got the high levels of vibration, noise is produced and the vibrations they can also cause the machinery failure. Now the reasons of vibrations may be different for different systems. Vibrations may be caused because of misalignment, looseness, wear or imbalance in the machinery. So there is high demand to reduce the noise, whether it is the plant or a single machine. So for that, vibration isolators are used. So what is the function of vibration isolators? They reduce the noise and vibration by creating, or we can say by controlling the vibrations at the path of the traveling of vibration from the source to the receiver. So these vibration isolators, they find their applications everywhere because what they are doing, they are controlling noise and vibration. So they can be used in offices, homes, studios, theaters, schools, hospitals, plants, everywhere they find their applications. Now, whenever there is a machine which has got vibration and that machine is mounted on some rigid support, so what happens? There is a higher possibility that the vibrations they can transmit to supporting structure, and from there they can travel long or the large distances and which may be emitted in the form of noise. So if you see that if there is a vibrating machine in any part of the building, the noise can be heard in different other parts also because the vibration that is transmitted to the frame or to the support, it travels through long distances and the noise can be heard at various places. So the aim is, or the idea is, to reduce this transfer of vibrations to the supporting structure. Therefore, we need correctly designed vibration isolators, and vibration mounts are one type of the vibration isolators that can be used. So some here you can see some of the pictures of the vibration mounts and they're varying in sizes and their designs. So basically the vibration mounts, they comprise of the material which is softer than the subfloor and the machine's feet. So that means the mounts, they're made up of two components. One is the rubber part and the other one is the metal component. So the combination of two things, that is the rubber and metal, it provides us the stiffness of the metal component, and rubber, it acts as the damping component, right? Now, regarding the placement of the mounts, they should be placed symmetrically around the center of gravity of the system, and the distance between the vibration mount, it should be greater than the vertical distance between level of vibration mounting and the center of gravity. Now in this we can see a picture. So this is the mount which is being placed to balance this system. Now we see whatever is the equipment that we are using for mounting, it will have almost at least one natural frequency. So there may be more frequencies, but let's assume even if there is one natural frequency, and in case the disturbing frequency of the machine or the system, it coincides with the natural frequency of the mount. So what will happen? The vibrations, they will get amplified. The condition of resonance will be there. So uh, while designing a vibration isolator or a mount, it is always required that the natural frequency of the equipment should be much less than the disturbing frequency of the system or the machine. Now, we say that whenever we are designing the mounts, they should be able to reduce vibrations by more than 70%, right? That means to say that design, it does not work when the isolation is lower than 70 degree. So if we see a graph that is plotted between the disturbing frequency, which is given in hertz, the natural frequency of the isolator, and the isolation percentage, you see at around the 70 percentage condition. So this is given in percentage. You see that this is showing the condition of resonance, which is actually the unsafe area, because if the frequency, the working frequency of the system, it coincides with the natural frequency, the amplitudes will be very high and it will damage the system. So this is of course not a desirable condition. This is quite an unsafe area. So usually we design in these regions where the isolators are working with efficiency with the isolation percentage more than 70 degree. So usually it is targeted at somewhere around 95, but it may vary depending upon the requirement of the system or the machinery. Now, we have already discussed that these mounts, they comprise of two components, that is the rubber and the metal component. So the rubbers that are used, they may vary depending upon the requirement. So natural rubbers can be used which have got high elasticity, they have high tear strength, and they are quite the strong materials which are the best resistance to mechanical and dynamic loads. But again, they have certain disadvantages. They are not stable, especially with the non-polar liquids. So some additives can be used to make them more efficient, right? Synthetic rubbers can be used which are heat resistant. Then the components, various components can be used as per the requirement of the machine and the system. So various combinations can be used to create vibration isolation mounts.